Good day, viewers. Good day. I will come into this presentation. Here we're going to answer this chemistry question. So now the first question is to find to explain what is meant by limiting reactants. So when you talk of the reactants here now, we call this reactant as the one that is able to finish completely or fast before the other reactant can be finished in a chemical reaction. So here the answer, we are saying that to explain what is meant by the limiting reactant, we are saying that is a reactant. Okay, we are saying that a reactant that is able to finish completely in the reaction before the other one can be finished, that is what we call a limiting reactant. And the one that remains in excess, or the one that remains without being reacted, it is what we call excess reactant or reagent. So excess reactant, we say this is the reactants that remained unfinished at the end of the reaction. Okay, so we can proceed to the next question. 2.4 gram of magnesium reacts with 0.3 mole of hydrochloric acid. Okay, so this is the mole of hydrochloric acid. Write the balanced chemical equation for the reaction. So here we simply need to write the balanced chemical equation. Okay, so here to write the balanced chemical equation, 2 marks, you say magnesium, you have magnesium like this, so this is solid, okay, plus hydrochloric acid. Hydrochloric acid is HC like this, so this is aqueous. Okay, this is hydrochloric acid, this is aqueous. Then this one is going to produce, now this magnesium is going to displace what? Hydrogen. So what will be produced here is magnesium chloride. Okay, magnesium chloride. So here we had a 2 because the valence number of this magnesium is what? Is 2, and the HC it's just 1. So once we write the combination, it will be like this. So this is magnesium chloride aqueous, then plus hydrogen gas will be formed here, or hydrogen gas will be produced. So again, you need to check how many chlorine do you have here. You have 2 chlorine, there we've got 1 hydrogen, 2 hydrogen, 1. So here you add a 2 this side. Okay, once you add, then you check again. So you find that this equation is being what? Balanced. This is how we can write the balanced chemical equation. Okay, then we proceed. B2, determine the limiting reactant. Okay, so here remember we say that the limiting reactant is the one that is finished quickly in the reaction before the other reactants can be finished, and the one that remains is what we call the excess reactant. So here we are going to use this equation to determine which one is going to finish quickly than the other one. Okay, so we have here, we have been given the mass of magnesium, and here we have the moles of this hydrochloric acid. We have the mole. Now having this one here is a mole, so we are going to use we are going to find the mole of this one here, magnesium, to compare which one is going to finish faster than the other reactant. So here we have magnesium. To find the mole of magnesium, so we'll say N, okay, which is like this. Then I'll put magnesium here. Moles of magnesium is equal to, okay, is equal to here we know the formula is mass then over molar mass. Okay, so here we know when we talk of the molar mass of this magnesium HC 24, then mass here we have been given is at 2.4. So here we'll say it's 2.4 over 24. Okay, so now this into this, so here we can say this is in gram and this is gram per mole. Okay, so this gram and this gram will go, then this into this, it will give us 0, okay, 0.1 more. Okay, so this is 0.1 more of magnesium. Okay, so this is the more of magnesium. Then also have the more of hydrochloric acid, which is this one. So just having this more, as you can see, whether we use this one and we also divide here 2 into this one, we're going to have 0.15. okay, so as you can see, magnesium here is less than what? Magnesium here is less than hydrochloric acid. Once we write the ratio of this, okay, so we'll say ratio of moles of magnesium here. Okay, we'll say magnesium, then hydrochloric acid this side. Okay, hydrochloric acid here we have 0.1, and this one we have 0.30. Okay, so these are moles. Then as you can see, this one and this one, it is what? This one has got the lesser number of moles, so which means this one is going to finish quickly than what? Hydrochloric acid. So hydrochloric acid is going to have moles that will remain unreacted. Okay, so this one is called it's going to have moles that will remain unreacted. So here we are saying that to determine the limiting reactant, here we are saying that magnesium is a limiting what? Reactant. Okay, so here we are saying that therefore magnesium is a limiting reactant. Okay, so this is how we can determine the limiting reactant. Okay, so we move on. Okay, then here we have this question here, which is calculate the mass in excess for the substance which is in the excess. First thing, we have this equation here. You need to use this equation, which is magnesium like this, plus 2H chlorine. Okay, I just want to copy the chemical equation that we have. This one plus hydrogen gas. So having this equation, the one that is in excess, this one, so they want us to find the mass of what? This substance which is in excess. Then remember here we've calculated the mass of magnesium, the moles of magnesium, which is 0.1 mole. Okay, so this is 0.1 mole of this magnesium. So having this equation, and we have been given like the the moles of hydrochloric acid that was reacted here. It is hydrochloric acid. The moles that was reacted is 0.30 moles. Okay, so this is what the information that we have. Okay, moles. Okay, this is the mole of hydrochloric acid that was reacted with the magnesium. Then here the limiting reagent is this one. So the limiting reagent, the moles of limiting reagent is this one. So here we are going to use the this equation to find the moles of hydrochloric acid that reacted with what this magnesium. Okay, so here we are saying that here we know this is 1, so we say 1 more of magnesium this side. Okay, requires here it's 2 moles of hydrochloric acid. Okay, requires 2 moles of hydrochloric acid. So this is hydrochloric acid, this is 1, the coefficient of this magnesium. Then we've calculated to say the mole of this magnesium is what? 0.1. So we say 0.1 mole is equal to dash of hydrochloric acid. Remember here we want to find the exact mole that is required in this what experiment, not the one that was added. Okay, so this and this and this this and this will say x is equal to 2 by 0.1. so once you multiply this one, x is equal to 0.2 moles of hydrochloric acid. Okay, so this is the required mole of hydrochloric acid in this what experiment. Okay, so now this is the required mole of hydrochloric acid. Then here the question is just to calculate the mass in excess for the substance, and here the mass in excess for the substance is this one. Then here we have 0.3 more. This was the more that was being what reacted. So this is the more that was given. So we are going to find, since this one is going to be used up in this what reaction, so we will subtract this one from this one, and the one that we are going to remain with is the one that we are going to use for us to find what the mass in excess, because which means we are going to have the more in excess. So this one, it is the more that was added in this in the reaction. Then only the 0.2 moles of hydrochloric acid was used in the reaction. Now the one that remained reacted is the one that you want to calculate here. So to calculate that one, we'll say we are saying that hydrochloric acid, which was in excess here, now we say is equal to 0.30 minus 0.2. okay, 0.2. then here the answer will be 0.1 okay moles. This was in excess, moles of moles in excess. Okay, this was in excess. So here we are saying this is hydrochloric mole that was in excess. So having this mole which was in excess, now to find the mass also that was what in excess of the substance in excess, which is this one here, magnesium, will say N, which represents the number of moles, is equal to m over molar mass. Okay, then this and this will have m is equal to, okay, M is equal to N times molar mass, then is equal to here our N here, which is more, is this one, which is 0.1 moles times here the molar mass of hydrochloric acid, okay, which is H chlorine, like this. So here we have this one here, which is 1 by 35.5. This is the mass number, okay. This is the mass number of chlorine, it is 35 by 5, and here it's 1 by 1, which is the mass number of hydrogen. So when you add this and this, we are going to have 36. So here we have 36.5, which is gram per mole, okay. So this mole and this mole will cancel. Then 0.1 times 36.5. So here the answer that you get is 3.65 grams. So this is the answer that you get as the mass in excess. So this mass will remain what? Unreacted. Okay, unreacted. Thank you very much for following this content. Remember to subscribe and also share